So welcome to Java.LANG classes presentation. So in this presentation we are going to look into various set of classes under Java.LANG package. So these are the classes that we are going to go over in this presentation. So let's start with the string class. String class is probably the most frequently used class in your Java application in many cases. So it represents combination of character literals, and you can actually represent strings in two different ways: array of characters and string class. In many cases you are going to use string class directly. And string class comes with a various set of constructors. So here examples of creating string class object. So obviously you can use a new keyword to create the empty string object, and you can create the character array, and from the character array you can create a string object, and you can also create a byte array, and then from the byte array you can create a string object. And here you are creating substring portion of the character array to create a string object. So this is the starting position, this is the length of the characters. So this is going to have ELL in new S4 string object, and you can create a new string object from another string object as an input argument. You can obviously copy a string object to another string object. Well, actually this is the reference. We are having another reference S6 pointing to the string object pointing to by S2 as well. So moving forward, so this is the string class, various sets of method. So things are pretty much obvious. So character at returns the character located in the specified index. Compare to is comparing two strings lexicographically, and this is compared to ignore case. This is the lexicographical comparison, ignoring the case. Equals is returns true if the string has the same sequence of characters as that of the object specified. So we are going to take a look at some of these examples later on in hands-on lab, and I'm going to actually give you some demonstration. Equals ignore case. This is the case where two strings are compared with the equals ignore cases method and get characters. So these are somewhat obvious kind of methods, so I'm going to actually ask you to look into these methods using Java documentation as well as doing the hands-on lab. And length is the length of the string, and replace is the returns the string where in all occurrences, so you're actually replacing all characters with the new characters. Here substring, you are getting a substring from the index to end index -1. Okay. And here you're going to get the character array, and you're going to trim the leading as well as trailing white spaces from the string, and this is returning a value of. So it will evaluate the data type, and then it will return the string representation of it. So these are example code. Here we are getting character at index 2, and we are lexicographically comparing, and here we are lexicographically comparing again. This time we are comparing this one against Jonathan, and this one is name is Jonathan against Solomon. Okay, so they should actually return, one is in return plus, the other one is returning negative value. Compare to, so equals and equals ignore case. These are all kind of obvious methods. And you are creating character array from the string object, and you are getting get characters method from Jonathan string object, and getting the length of the string object, replace a character with the e character, and again you are getting substring of Jonathan. So here one thing I want you to remember is that this is the you are getting starting from here, and then this index -1. So in our case, the string object of name is a Jonathan, Jonathan. So from 0, and the 2 minus 1 is 1. So we are getting JO. So this is the end index, and we are getting end index minus 1. Okay, so that's what I meant. 0. So we are getting 0 and the characters at 0 index and index 1. So that's why you're getting JO. And here we are trimming things out. So here we are trimming the leading white space here, and trailing white space is here. So what you're going to get is just this as a string object. And here we are calling value of. So in this case, this is a Boolean data type. So we are just returning true in this case. Oh, actually, this is false, right? Okay. And that is okay. So one more thing to talk about. String is a finite class, meaning it cannot be changed or mutated. Okay. So whatever method you're calling to name, the name string object still remained as the initial value that was assigned. So once it's assigned, so because a string is a finite class, once this value is assigned to the string object, this string object cannot be changed. Alright, so let's run various sets of sample applications. So we are going to start with the string constructor. So let's run the application. And we have various returns of the string object. So if you take a look at the code. So here we are creating new string object, and then we create the character array. From the character array, we create the string object, so it should contain hello, and this is a byte array, and from the byte array we create a string object, and here we are creating a string object from the character array, specifying the starting point and the length. So if you want to see this particular constructor method, you can take a look at the Java doc. Let's actually see why Java doc is not working. Okay. So if you want to see the Java documentation, just right click it and show Java doc, and you are seeing here this is the string constructor method with 3 parameters. This is a character array, this is offset, and this is a count. Okay, so let's try the string demo application. So this time, string demo application, let's run the application here. So nothing really, yeah, so here these are the results. Let's see the code. So we have a string object, we just printed out, and then we are getting third character of the name. So here we are using character at and providing index, so it should return the n, third character, because this is index starting from 0, and convert the string to a new character array. So here this is the string object, and then we are calling 2 character array method to have character array object, and then we are using for loop to just display character array. And here we are creating character array object of the size of 20, and then we are creating a new character array. So we are basically from the Jonathan string, and then we got the get characters, and this is from 0 and 2, and this is the destination, the character array. And this is a starting point of starting point where these 2 characters, from 0 and 2, is actually the destination. So let's just see the result. Okay, so this is the result. So it's actually creating character array, and it's actually starting from the third location of the destination character array. So that's the reason we have some trailing spaces. And the next one is So length, and then we replace all the A to E, so we are now seeing Jonathan. And then we create a substring, and then this is a trimming. So if you see the trimming, the end result is of this, because leading white space and the trailing white spaces are removed. This is a value of, this is a Boolean, and the value of it is going to be false in this case, and this one is true. So we are seeing false and true. And again, the name string object should not be changed because it is not mutable. Okay, next one is object comparison and lex comparison. So we are going to take a look at the comparison method of string object. So let's see the code first. So we have, let's see, maximize it. So we create a new string object of JPassion, and then we create a new string object of JPassion as well. So in the second line, in this case, we have two string object instances. Even though they happen to contain the same string values, they are two different object instances. So if you're trying to use this double quotation, double equal sign, which is actually comparing whether they are pointing to a same single object or not, it should return false, because they are pointing to different object instances, even though they contain the same string values. However, if you're using literal in this case, we are using literal to create the string object. So in this case, literal object is in fact they are same. So Java is intelligent enough to have a single instance of literal, string literal object. So when you are comparing S3 and S4, they are in fact pointing to a single JPassion string object. So in this case, it should return true. Here, if you want to see whether a toString object in fact contains the same string values or not, you want to use the equals method. So in this case, the name is Jonathan, and then we are comparing another Jonathan. It should return true. Okay, and here we are comparing capital J Jonathan and lowercase Jonathan. Obviously, they should refer to point to two different object instances because they are not the same value, so it should return false. In this case, if you, I'm sorry, this equals method. I'm not really talking about this double equal sign semantics. So here, whether, so when you use equals, because they are different in terms of capital and character and lowercase character, they are different. However, if you want to have equals with, if you want to use equals, ignore case, then it will return true, because regardless of the case, should return true if you're using this method. Okay, so that is somewhat straightforward. Now the last lex comparison, lexicographical comparison. So this is the application. So we are using compare to. So compare to, if you take a look at the Java documentation, compares to strings lexicographically. So this lexicographical comparison is based on Unicode of Unicode value of each characters in the string. Okay. So if you run the application, depending on the Unicode representation of the characters, it will return negative value or positive value. So in this case, Jonathan compared to Solomon, it returns negative value, and here Solomon is compared to Jonathan the other way, it will return positive value, and here Jonathan is compared to lowercase, capital J, Jonathan is compared against the lowercase Jonathan, it returns minus value, and here we are comparing to ignore case, in this case returns 0. Okay, now let's move on to StringBuffer class. So as I said before, the problem of string object, well, it's not a problem, it's just the way it is designed. The string object cannot be modified or changed because it's a final class. So what that means is the contents of the contents and of course the length of the string object cannot be changed. Now, if you want to manipulate the string object, well, you know, you want to use a different the class called the StringBuffer class. If you're using string object and change string object to something else, what happens underneath is that it will actually create a new string object and then copy the contents from the old string object to the new string object, and it is actually pretty costly. So whenever you need to manipulate the string object, you want to use the string buffer object rather than string object. So string buffer object is pretty much the same as a string object, but it's mutable. Okay. So what that means is the contents and the length of the string buffer object can be changed. So a few methods of string buffer class. It's a capacity. You can return. You can actually call capacity method to get the current capacity of the string buffer object, and you can append it. You can also get the character add, just like a string object, string class, get characters, and you can delete some characters, and you can insert some characters. And so you can get the capacity, and you can append it. You can get the character add, and you can change to character array, and get characters, and so. Yeah, and also you can also get the length of it, and you can replace it, and you can also get the substring of it. So you can see StringBuffer class has some similar method, and it also has extra method for manipulation of the string buffer object. Okay, so let's see this string buffer sample application. So this is a string. We create a string buffer object, initializing with the Jonathan as a string value, and obviously it should print a string. And initial capacity is 16. So if you actually call capacity method, it will return 16. So let's actually just try to run the application, see whether that is the case. String buffer demo. Okay. Oh, okay, capacity is actually 24. Okay. That's initial capacity. That should change to 24. Okay, you can append it, and so once you append it, you can see it is appended, and you can get the third character of the string buffer object. You can change the character array, and you can get the so here you are copying some characters into character array, and then we are basically okay. So here we are getting the length of it. This is insert, delete, and we get the length and replace it, and we also perform substring. Okay, and when you actually print out at the end SP, the string buffer object, obviously it should not be initial value because we actually changed quite a bit. Okay. So this is the final value that has been changed into string buffer object. Okay, wrapper classes. I think we touched upon wrapper classes a couple of times already. So primitive data types are designed to provide a better performance. However, they are not objects. So if you cannot actually call any methods of object class whenever you're dealing with the primitive types. Okay. So only actual objects of the object class are in fact allowed to be called with the object methods in object classes. So whenever you need this kind of object representation of these primitive types, then you are going to use the wrapper classes of these primitives. So there are matching wrapper classes for all these primitive types. Okay? So examples are something like for Boolean primitive type, there is a Boolean, capital B, wrapper class. This is the genuine class, so meaning this is the subclass of object class, for int, integer, long, and double, and there is a few more like a float. Okay, so this is the Boolean example here. So you can, this is the, we are using Boolean primitive type. Now you can create the Boolean object from the true, the initialization value. And here we are again creating Boolean object again. And then we are basically just displaying things. So as far as the functionality is concerned, it should work pretty much the same as the primitive type, but it is a genuine object. So you can use the equals method of object class, and so in order to actually get the object to primitive, what you do is you call Boolean value method or int value method to get the primitive object, primitive type. Okay, so wrapper class examples. Okay, so this is the code that we just have seen in the slide. So this is the primitive type Boolean, and then we're creating Boolean object instance. We also create the another Boolean object instance, and so object to primitive. So in this case, you're going to call Boolean value method of the Boolean object to get a primitive Boolean type. And here it works pretty much the same. So we create integer object, and then we get the and this is the conversion from the object to primitive type. By the way, from SDK JDK 1.5, there is a concept of autoboxing is supported. So you know we are going to actually take a look at those things when we talk about the JAVA.SE 5 features later on in this course. And the long, so this works pretty much the same. This is double. Okay, moving forward. Math class. Math class is a convenient class that lets you perform various math operations: round, square root, change to degrees, and radians. So a bunch of absolute value and getting the random number, and you can see these are all static methods because these are all convenience methods. You want to actually execute to perform some mathematical functions. So these are setup methods. Okay, so we are getting absolute value. So this is going to return both 5, and this is for generating random number. And this is a max value between the two, minimum value between the two, and getting the ceiling. So this is double type. This is a floor, so the value just below it. And the e is raised to 1 exponential, logging, and power of 3. Okay, so these are some really obvious things. So let's just run the application and move on. Math demo. Okay, so a bunch of math functionalities. Okay, so you can see a bunch of math functionalities being supported through math class. Okay, moving forward, system class. System class you have used quite often up to this point, especially system.out.println method, right? So it provides useful methods and fields for standard input and standard output, and it provides some utility methods for fast copying of part of an array. So here, array copy, and you can also get the current time in milliseconds. And so here, this is the so this is the difference between current time and the UTC time. Okay, so this is all measured in milliseconds. And when you call exit, your application exit out. And go is actually GC. Runs the garbage collector. It's actually, it's basically you are asking the system to perform garbage collection, but it's not always guaranteed that it's going to run right away. And set in, change the stream associated with the system in with another input stream. Same thing for print stream here. Set out. So here we are calling current time in milliseconds, and you got the start time, and you perform certain operation, you get the end time, and you can actually find out how much time has passed. And this is a fast array, so array 1, array 2, and we are basically copying this length of array 1 to array 2, starting from this is the starting position. You can ask, well, it's not really forcing garbage collection to the system. You are basically telling system, I'd like to have a garbage collection done right now, but it's up to you whether you want to do it or not. But basically indicating that you want to do some garbage collection at this point. And setting the input stream to standard input device, and when you call exit with 0, then you are exiting out application with a success. Okay, there are a bunch of system properties: Java.version, Java.vendor, Java home, and VM specification version, and things like that. So these are system properties that you can actually find out. For example, operating system architecture, OS version, and file separator. So depending on what operating system using, file separator could be the / or /, and username and user home, user directory, and these are the things you can find out. So when you call from the system class, you can call get properties method of system class, and then you can find all the values of those. Okay, so this is basically the result. When you run that application, you're going to see the values of all these system properties. Okay, so let's run. So let's run the system properties example first. So you can see it's displaying all the system properties. So in my case, the Java version is 14.3 B01, and the separator is the separator semicolon, and so these are the system properties that are returned. So if you take a look at the code, very simple code. We call get properties method of the system class. So this is obviously static method, and once you got the properties object, then we can display things out. And there is a system class. So this code is it basically shows you some method of system class. For example, current time in milliseconds, and then we subtract it. So if you run this application, it basically shows how much millisecond has been passed for performing this operation. And we asking the system to perform garbage collection. We are setting the standard input with the temp.txt file system, and then here we exit out. System class number 2, this application is okay, so you can also get the environment variable. So if you run this application, yeah, so these are environment variables in my system. Okay. Right. Moving forward. Okay, process and runtime classes. So process provides methods for manipulating. Okay, so process class provides a methods for manipulating processes. For example, killing process, running the process, and checking the status of process. So destroy, wait for okay, now moving forward, runtime class represent the runtime environment. So you can call the static method of get runtime to get the runtime object. You can also called exec method, and providing the name of your application, OS specific application, then it will run that application. So in this case, I create the I get the runtime object by calling get runtime method of runtime class, and then I can perform some OS specific application like a regedit or a notepad or something like that. And here, when you call wait for, this particular thread is waiting for this process to finish. Okay. Alright, so let's try to run few runtime class examples. So let's try runtime exec first. So in this case, this is I'm checking whether my system is Windows or not, and if it is Windows, then I'm running Notepad application. If it's not, I'm actually running gedit application. And then my thread is waiting for this particular process to finish. Okay, so let's run this application. When you run it, it's going to start this Notepad application. Now you see it is printing up before calling wait for. So now my thread is actually waiting for this Notepad application to be finished. So if I exit out, then you can see now this is the controller is coming back from this method, and then you see this one is being displayed. Now if you comment this out, if my thread is not waiting, then it's going to just run the application and exit out. Start the application, exit out. So in this case, my application is already the exit out. Okay. Moving forward. Okay, memory and the get runtime. So runtime method also has, let's take a look at the code. Runtime class also has some memory related method. For example, you can find out the max memory and total memory. So if you run the application, okay, so this is the maximum amount of memory that the Java virtual machine will attempt to use, and then this is the total memory, total amount of memory currently available in the current and future object. Okay, so moving forward, get runtime. So this one is okay, so get runtime here. This is the case that you are calling so this is a command array. I want to execute, for example, Java P minus private and string class. So Java P is basically disassembler. If I run this application, for example, Java P as private and Java.LANG. It basically gives me all the list of the methods and fields and things like that for that particular class. So suppose I want to run this application. Basically you are going to have that command array, and you set the environment, and then you get the runtime object, and then you're going to provide you're going to call exec method with the that array of commands and then environment, and then you're basically displaying things out. So if I run the application, it will actually display the same result which I just did with the command line. Okay, moving forward. ProcessBuilder class. So in JDK 5 and before, the only way to fork off a process and execute it is in fact what we just did using exec method of the runtime class. However, runtime class is kind of not flexible. So JDK 5 has a new way of executing a command in a separate process through a class called the ProcessBuilder. So ProcessBuilder is a bit more flexible class. So why ProcessBuilder class? Because runtime exec approach doesn't necessarily make it easy to customize and invoke subprocesses. So new ProcessBuilder class simplifies things. Through various methods in the class, you can easily modify the environment variables for a process and start the process. So it provides this flexibility of actually kind of customizing your environment before you're starting to run an application. Okay, so streams is all standard. Yeah, so standard input and output operations will be redirected to the parent process through 3 streams. So this is the way you can redirect to the parent process. Okay, so this is runtime exec example as we have seen, right? So basically you have a command array, and then you got the environment, and then you get the runtime object, and then you are calling exec method of that runtime object. In ProcessBuilder, these are the flexibility I'm talking about. You can create a map of environment variables. Okay, and you can also set the working directory, and then you can run. Okay, so ProcessBuilder provides more flexibility in terms of customization of running your application. Okay, and this is a case that you are capturing output and errors through different streams. Okay, so let's run ProcessBuilder. So the result is going to be the same, but it's using ProcessBuilder. So we are actually doing the same thing. We are actually running Java P minus private and Java.LANG.CLASSES as we have done. Okay, so it does pretty much the same thing as runtime exec, but provides more flexibility. So here we again create the ProcessBuilder object, providing that the array of string object, and here we are setting the environment. And then we are creating some working work directory, and then you run it. Okay. All right. So that is the end of the presentation. Thank you.